Question 18 says a well-stirred liquid is kept into surrounding. Temperature T of liquid varies with time T as shown. Value of X in degree C as shown is. So we have been given variation of temperature of the liquid which is cooling in a surrounding of temperature. From this it's clear that X is the temperature of the surrounding because as T is tending towards infinity, the temperature of the liquid is tending towards X. So the question is based on Newton's law of cooling. We can apply Newton's law of cooling, and the Newton's law of cooling simply says that rate of cooling, that means minus dt by dt, where capital T is for temperature and small t is for time, is equal to some constant of proportionality into T minus surrounding temperature, which we can put as X here, right? Now at 2 points, the value of minus dt by dt can be given from the graph. So when temperature T is 80 degrees C, minus dt by dt, the slope, the negative of the slope is tan 60 degree, that means root 3. So we have root 3 units is equal to the constant of proportionality k into temperature is 80 degrees C minus x, and similarly at 40 degrees C we have tan 30 degree, that means 1 by root 3. So the magnitude of slope is 1 by root 3. So 1 by root 3 is equal to k into 40 minus x. So we have these two equations. We can divide one with the other, divide 1 by 2, and if we do that we will get 3 is equal to 80 minus x by 40 minus x. Let's solve it. So 120 minus 3x is equal to 80 minus x, or 2x is 40 and x is simply 20. So for question 18 the answer is 20. Let's go to question number 19 now. Question 19 says, in the system shown, 2 kg block is projected towards spring with 2 meter per second at t equal to 0. Speed of 2 kg block becomes 7 by 5 meter per second for the first time at t equal to t naught second. Find the value of 60 naught. Pi square is given as 10, and this is the arrangement shown. Well, there is the concepts involved here are the conservation of linear momentum, motion of center of mass, and oscillations. When the block of 2 kg mass is in contact with the spring, it will be like 2 block spring oscillation, where we can apply the concept of reduced mass. But before that, okay, so to find T naught, well, T naught will consist of two parts. One where the block will move with uniform velocity of 2 meter per second to cover 3 meter, and then there will be oscillation. There will be in fact SHM of the block in the center of mass frame of the two blocks. So the first interval T1 is the time when the block gets in contact with the spring, and that time T1 is given as 3 divided by 2 second. Now when we have a 2 block system, it is given that the final velocity, the velocity of 2 kg block becomes 7 by 5 meter per second for the first time. So let's have the velocity of center of mass of the 2 block system first, and that is equal to 2 into 2, that means 4 divided by 5, or simply 0.8 meter per second, and 7 by 5 is 1.4 meter per second. But when the velocity of 2 kg block is 1.2 meter per second towards right, its velocity of the block with respect to center of mass will be 1.4 minus 0.8. The velocity of center of mass is going to be constant. So 1.4 minus 0.8 is 0.6 meter per second at that instant. The maximum value of velocity of the speed of 1 with respect to the center of mass is actually 2 minus 0.8, that means 1.2 meter per second. So we can write that the velocity of the block of 2 kg V1, let's call it velocity of 2 kg block in the center of mass frame, is its maximum value, which we just found, is 1.2 meter per second into cos omega t in meter per second, and this means that we have 0.6 is equal to 1.2. This gives us cos omega t as 1 by 2 and omega t as pi by 3. So this time t is pi by 3 into omega. Let's find the value of omega. Omega is under root of k, which is, let's say, k by m reduced, and this value is coming out to be 12. The reduced mass will be 3 into 2 by 3 plus 2, that means 6 by 5. So this omega is coming out to be under root 10 radian per second. So this time t will be then pi by 3 into under root 10. Now we can take pi as under root 10 because pi square is given as 10. So we have this time is 1 by 3 second. So the total time will be t1 plus t, and that is equal to 3 by 2 plus 1 by 3. This is 6. This is 9. This is 2. This is 11 by 6 second. Now this is nothing but t naught. So the value of t naught is 11 by 6 second, and so the value of 60 naught will be 11 second. So that means answer to question 19 is 11. Let's go to the last question of this test now. Question 20 says, for a planet of radius r and mass m uniformly distributed, gravitational pressure at its center is 3 by y gm square by pi r to the power 4. Find the value of 2y. Okay, so we can apply the concepts of both fluids and gravitation here. Say this is the planet and we are at distance r from the center, and let's say the r increases by dr. So between these 2 points, we know that if the pressure is considered as a function of r, then we have here dp by dr is equal to minus rho g, which is existing there, right? Rho and g. Rho of course is constant, but g will be variable here. And the value of g there can be taken as capital G. Whatever mass is contained within the sphere of radius r, that means 4 pi by 3 r cube rho by r square. We need to simplify this. This will simply be equal to minus 4 pi by 3 capital G rho square r. And so we have dp is equal to minus 4 pi by 3 g rho square r dr. Let's integrate. At the outermost point, pressure can be taken as 0. So that means when small r is equal to capital R, pressure is 0. And at any point, in fact, we have to find pressure at the center. So at r equal to 0, let's say pressure is P. So pressure at the center P, we can call it PC, is equal to then 4 pi by 3 g rho square, and this will be r square by 2. Now we have to get rid of rho and put capital M there. So we know that rho is equal to capital M by 4 pi by 3 r cube. So let's substitute that. What do we get? We get 4 pi by 3 g, and square of this will be 9 m square by 4 pi square r to the power 6 into r square by 2. This can be still simplified. We remove the square, and this is 3. So this is equal to then 3 capital G m square divided by 4 pi r to the power, in fact, well, there is 2 also. This is 8 pi r to the power 4. So we can see that the value of y is 8 here, and so 2y will simply be 16. So our answer to question 20 is 16. Well, students, with that we come to the end of this quick solutions. I hope you found the solutions useful. I wish you all the very best. See you. Bye. Take care.